Assalamu alaikum wa rahmatullahi wa barakatuh. I again welcome you to my chemistry class of states of matter, which is the continuity of the previous lecture, lecture number 1, which was on states of matter based on unit 1 according to IGCSE syllabus. Which was issued for the session 2023 to 2025. Right, so this is lecture number 2, the continuity of the previous lecture, in which we will be going through the change of states along with the heating and cooling curves. We will explain these curves in the light of kinetic particle theory. So let us start with change of states. So these are the names of change of states. Solid changes to liquid, the process is called melting, and liquid changes to gas, the process is boiling or evaporation. Sometimes solid, they directly change into gas without being changed into liquid first, so the process is said to be sublimation. When a gas is cooled down, or we decrease the temperature of gas, so gas is changed into liquid, and the process is said to be condensation. All right, and a liquid is solidified again, and the process is called freezing. So sometimes gas do not change directly into do not change first into liquid, but they change directly into solid. The process is said to be deposition or desublimation. If we explain the change of state in the light of kinetic particle theory, so we say that when we heat a solid, so the average kinetic energy of the particle increases. So we can say that when we heat a solid, so the particles, they gain kinetic energy, and the average kinetic energy of the particle increases. Average kinetic energy of the particles increases, right? So we can say that temperature, because average kinetic energy is nothing but the temperature, so temperature increases. When temperature increases, the particles, if they are vibrating, so they will vibrate more with more speed or greater speed, so we can say that particles move faster. All right, particles move faster and they go further apart. Why they go further apart? Because the attractive forces between the particles are overcome, because the attractive forces are overcome, right? So this is how we can explain when the state changes from solid to liquid and then liquid to gas. Coming to heat released, when we have a substance in gaseous state, so what happens when we decrease the temperature? So the obviously average kinetic energy of particles will decrease, and the temperature will also decrease. So we can say that temperature of the particle decreases, temperature of the particle decreases, right? When temperature of the particle will decrease, eventually particles will start moving slower. So particles move slower, right? When particles move slower, so they come closer to each other. They come closer to each other. Because attractive forces increase. Because attractive forces between the particles increase. Right? So this is how we can explain in the light of kinetic particle theory that gas changes to liquid because temperature decreases and particles become closer to each other. Particles, they start moving slower and they come closer to each other, and attractive forces between the particles increase. And the same explanation can be written when liquid changes to solid or gas directly change to solid, right? So coming to heating and cooling curve now. Okay, so this is the heating curve, the same idea which we discussed in the previous slide. Okay, so it is a solid, and when we heat a solid, the temperature increases until a point reaches when solid particles, they start changing into liquid, and this point is called melting point. Right? At melting point, solid, they starts changing into liquid without increasing the temperature. Why temperature does not increase? Because the heat which is being supplied to the solid is utilized to overcome the attractive forces. So temperature does not increase until and unless all the solid particles, they change into liquid. When entire solid changes to liquid, then temperature again rises up. Okay, until the point reaches where liquid starts evaporating, and that is called boiling point. That temperature is called boiling point of that liquid, and temperature will not rise until all the liquid changes to gas, right? So during melting and during boiling, and the temperature does not increase because the horizontal flat line shows that the change of state is taking place, and heat energy during this phase does not increase the kinetic energy of the particle, but it is used to overcome the attractive forces between the particles, right? So moving on, cooling curve now. So cooling curve is just a vice versa or opposite to that of heating curve, in which a gas is cooled down. All right, so the temperature of the gas decreases until unless a point reaches where gas starts changing into liquid, right? And this point is same as the boiling point, and this is called condensing point, and the process is called condensation, right? So the change in temperature, or when we decrease the temperature, so kinetic energy of the particle also decrease. But when the cooling down, the cooling process, basically what does it do with gas particles? It increases the attractive forces between the particle without changing the temperature. So once all the gas particles, they are liquefied, so temperature again starts going down until and unless a point comes where a liquid starts changing into solid, and this point is called freezing point, because the liquid starts freezing, and freezing point is same as the melting point. Okay, so a liquid starts changing without changing in temperature. So in this stage where liquid is changing into solid, the process is called freezing. You can say that when we cooling down the substance, and the energy is basically is released, and the attractive forces are increased, and particles, they come closer to each other and they arrange themselves as solid particles, right? Once the entire liquid changes to solid, what happens? Then the temperature starts decreasing again, right? So this is the cooling curve, which is exactly opposite to that of heating curve. All right, so hope you understand the change of a state and heating and cooling curve in the light of kinetic particle theory. So hopefully we will see you again in lecture number 3, which will be the series of the 3 lectures. So don't miss lecture number 3. So inshallah we'll be completing a chapter in the next lecture. So till then, Allah Hafiz, wassalamu alaikum wa rahmatullahi wa barakatuh.